Hello and welcome to this IChemE Global Awards 2021 webinar. My name is Matt Stalker and I'm your host for today's presentations. The IChemE Global Awards celebrate chemical, process and biochemical engineering excellence and are widely considered as the world's most prestigious chemical engineering awards. Today we'll be revealing the winner of the IChemE Team Award, sponsored by Baker Hicks. This award recognises the team that best demonstrates the implementation of a project, process, product or service within the chemical and process sector. Now, before we check out the contenders, let's find out more about our sponsor, Baker Hicks. Everyone at Baker Hicks is busy working on exciting projects, so they are interested in adding new members to their growing teams. Whether you're an engineer or work in a supporting role, they have a diverse range of project opportunities across the UK and in Europe. Okay then, so a big thank you to our sponsor, Baker Hicks. Right, let's move on. Our awards judging panel has been hard at work in recent weeks to review and rank all of the entries, and these are our finalists. We have a joint entry from Energy Australia and Oricon, Imperial College London, a joint entry from Imperial College London, UCL and the University of Oxford, Engro Polymers and Chemicals, Johnson Matthey, and finally a joint entry from Petronas and Malaysia LNG. All of our finalists join us today to tell us more about their work, and you can get in touch with your questions throughout the webinar using the GoToWebinar questions box on screen. So let's get started with our first finalist, and we have a pre-recorded presentation representing the joint entry from Energy Australia and Oricon.
Good afternoon, folks. My name's Glenn Schumacher. I'm Head of Engineering for Energy Australia, one of Australia's 3 large vertically integrated energy suppliers. And we are here today to talk about our journey as a team in the world of process safety. And I'll hand over to Lara from Oricon, who have been our partners in this journey.
Good afternoon, everyone. Hi, my name's Lara Kays. I'm an associate with Oricon. And yes, Shu and I would like to thank you for this nomination to be a finalist in the team awards. We're very, very grateful, and we appreciate the opportunity to share some information about our submission this afternoon.
So let me tell you a little bit about Energy Australia. As I said, we're a vertically integrated energy company here in Australia. We generate electricity. We've got about 7 operating sites across the eastern, southeastern section of Australia, where we produce electricity. We are active in the energy trading area in both gas and electricity, and we're a retailer of gas and electricity in Australia. As I said, 7 sites, all with very different backgrounds, different technologies, geographically dispersed, and different ownership structures over many years. And we're trying to pull that together as a portfolio. And so we've been facing some very challenging times in doing that. And one of the tools, one of the foundations build is process safety across that portfolio to get a common language, a common thinking about how we make our plants safer places to work. And we've done that in partnership with Oricon. Critically to us has been, as with all of the energy industries around the world, we're facing a massive transition, a transition to new technology, a transition to sustainability. However, we've got legacy assets that we've got to keep operating. We've got to keep operating them safely and reliably as we go through that transition. And there are many challenges that lay in front of us as an industry. And to do that, the core fundamental thing that will make that transition happen and do it in a safe, controllable manner is our people. So when we start to think about things like process safety, we look at those things through a lens of our people. How do we engage with them? How do we empower them? How do we bring about a change in culture? How do we build a future for ourselves? And so we take a very different view when we approach all of these things. But process safety for us grew out of a very bad situation where we had a fatality here at one of our power plants at the end of 2018. One of our own lost his life in his working day in what was a process safety failure. And that was a wake-up call for us that we needed to do things differently. We needed to think differently. We needed a different approach. And so we've taken a very different approach to how others have approached process safety. We went out looking for a partner in this, people who could bring process safety subject matter expertise, but could understand the kind of environment in which we wanted to deliver it and how we wanted to deliver process safety. And we found that partner in Oricon, and they've been on the journey with us. So let's hear a bit about Oricon.
Thanks, Shuey. Yes, so Oricon is an engineering, design and advisory company, but not as you know it. We've reimagined engineering. As Shuey mentioned, our clients' ideas and aspirations drive all that we do. We work alongside, not like other firms, and we co-create innovative solutions to some of the world's most complex and challenging problems. We serve our clients across a range of markets and international locations. Hardwired in our DNA, our engineering design, and our deep need to leave a legacy. We are as diverse as we are dynamic. We are as clever as we are curious. Drawing on our deep pool of knowledge, we bring vital engineering experience, technical capability, and design expertise to the table. But then we listen deeply and intently. We see the opportunities, the possibilities, and the potential that others don't. Through a range of unique creative processes and skills, we collaborate with our clients to reimagine, shape, and design a better future. We believe humanity depends on engineering, and we recognise we have a broad stewardship role to play and a deep responsibility to hold. As we continually strive for a life of balance, Aurecon's clients will be ready for a future and engineered for life.
Thanks, Lara. Here in Australia, the energy industry has a good safety record, but our safety processes and focus developed and driven over many years has really been around what we call occupational or personal safety, about the individual. We colloquially refer to it as slips, trips and falls. However, process safety is different. Process safety really is dealing with those rare events that sometimes we haven't even experienced, but when they do happen, the consequences are significant. As from the example of our colleague who died at work, the consequences can be the ultimate price, and he paid the ultimate price. And we want to make sure that never happens in our organisation or indeed our industry ever again. So hence our focus on process safety. But as I said earlier on, the core of this is people. And it's about explaining and educating people around process safety, engaging with those people, getting their ideas, their knowledge, their experience, but empowering them to ownership of process safety. It's about cultural change. It's not a project. It's about changing how we do things going forward. It's about the future. It's about us and the place we work being safer for us to work in. And that's the journey we've been on. And we've been on that journey with Aurecon as a close partnership. And that's been an important indication of how we see people working collaboratively. And Lara can give you some examples of how that's played out.
Thanks, Shuey. Yes, as Shuey's mentioned, the objective was to implement an organisational wide process safety plan, and it was really important that it was in a collaborative team approach. So firstly, we identified the problems that were facing the group using Aurecon's Design to Innovate principles to really ensure we unearthed all of the things that we needed to address. And then the first step after we'd done that was to understand what the major accident hazard risks were using risk assessments. And we engaged multidisciplinary teams to complete the risk assessments, but not as you know it. We knew that we had a lot of visual thinkers and people who like to be on their feet to work rather than in front of computers. So instead of spreadsheet risk assessments, we leveraged the knowledge of our people to create an interactive picture of the risk on the wall, literally. The bow tie risk assessments using the bow tie risk methodology to describe the major accident hazards were a 2x4 metre canvas. This increased interaction and most importantly, allowed the workshop participants to feel ownership of the outcomes and the way forward to close any gaps identified. Wishing to engage across all of our workshop, we knew we needed to make sure we broke down any barriers that were preventing engagement, and some of these barriers were actually surprising. One example was we found that a number of the people were colourblind, and the colour coding we were using was preventing their full engagement. So we developed a solution. We started to use patterns with the colours to indicate information on the bow tie, and this enabled them to easily interpret the information. The final example I wanted to talk about in terms of how we collaborated and built the team is the cartoon on the screen. We created unity and a clarity of common purpose with this cartoon around safety, and it really captures the creativity of the team and is a way that we could share the message very simply. One of the participants in our early workshop was chatting to his colleagues around how he understood process safety and the concept of process safety. And he used the analogy of personal safety is like falling down the stairs, while process safety is the stairs falling down. We felt this really resonated with the group, so we took the idea back to our Oricon graphic designers and made it come to life, and is now the most recognised definition of process safety in Energy Australia. The process safety cartoon was a simple, innovative way to help build the team.
Thanks, Lara. And it is an example of this idea coming from our employees and using this now all the way up to our board to educate them and explain about process safety. So it's become a powerful tool which well illustrates that level of engagement. So thank you very much for the opportunity to talk with you this afternoon. Thank you for listening. It's been challenging times for all of us, so we ask you to stay safe. For us, at the end of the day, the important thing is the safety of our people and creating a safer, more engaged workplace. But in sharing this journey, we hope there's something of interest to you. And if you're interested in reaching out to us, we're more than happy to talk about our journey, a journey which we hope will go long into the future. As I said, this is not a project, it's how we do things going forward. Take care, stay well, stay safe. Thank you. Bye.
Bye.
Okay, that was a pre-recorded presentation, so no Q&A with our first finalist, I'm afraid. But next up, live, representing Imperial College London, please welcome James Campbell and Vijesh Boot.
Hello, everybody. Thank you. My name is James Campbell. I'm a teaching fellow at the Department of Chemical Engineering at Imperial College, and I am here with my colleague Vijesh, who is also a teaching fellow, to talk about the CREATE Labs, which you can see stands for ChemEng Remote Experience Augmented Through Technology. That was a name that was actually come up with by some students from a competition that we ran to name this approach for teaching our labs during the pandemic, which demonstrates the collaborative approach that we had for how we would tackle this problem. Okay, so in the UGU Labs, just an introduction, the UGU Labs Imperial College, we teach over the first 3 years of our MEng course, over 450 students across 26 projects. And we have 3 modules for this, known as Foundation, Knowledge, and Discovery Labs. And we try to increase the amount of freedom that the students have in their projects. And we wanted to retain this during the pandemic when we couldn't conduct face-to-face teaching. So when the pandemic happened and we realized we couldn't conduct face-to-face teaching of our labs, we wanted to make sure that we could maintain our learning outcomes of the traditional labs in face-to-face teaching. But we also realized there was a number of opportunities that could happen when we were undertaking remote teaching. So firstly, we wanted to use this as an opportunity to prep students for Industry 4.0. So the GTAs, our graduate teaching assistants that we had in the lab working on the experiments, would act as operators, and our students would be instructing them remotely as process engineers, and that would mimic what they're most likely to do in their future careers. I also wanted to use this as an opportunity to build essential leadership skills. So being able to deliver clear instructions to someone, but you're not directly there, is a key skill that the students are going to have to develop, and was made more possible using our CREATE Lab approach. And also we wanted to develop the use of digital twins, so we could allow to recreate the experience of carrying out an experiment on a piece of equipment that can give you results from anywhere else in the world. And to do that, we would use various tools that Vijesh will discuss.
Okay, we seem to have some audio problems. I'm not sure if we're picking up background noise or it's your mic suggestion that you can't understand. We're still not hearing anything other than background noise at the moment.
Hello.
Hello, that's better. Yes, we can hear you now.
Okay, great. Right, so I'll start again. So the Create Labs approach used different tools, so including the digital twins aspect that James just mentioned. So in this case, so in the top with the planning stage, we provided students with virtual simulations of the actual rigs of the pilot plants which are there, and this basically gives them an insight into understanding what the different resources they have and design the experiments as well. But the real challenge was how do they conduct the hands-on experiments, and this is where we had a lot of our team included a lot of graduate teaching assistants who acted as process engineers who basically use the instructions that the students would provide and guide and then operate the equipments. But it isn't just operating the equipment, because we didn't want just the GTAs to actually do things. We also wanted students to engage with it. And so we had a lot of software as well as equipment which were remotely operable. So students from anywhere in the world could use these pilot plant scale equipment from anywhere in the world. And this was achieved by using MS Teams, remote access functions. And the second aspect of the experiments is the observation. So they should be able to see as well as interact with the rigs. And for this, we use state-of-the-art tools, including the Microsoft HoloLens, and we work very closely with Microsoft throughout this process. We had several teams of Microsoft working with us to ensure that the HoloLens device works in this context. And this is the first time that we were able to use this. And then the PTZ cameras, which is the pan, tilt, and zoom cameras, provided high definition view of real-time equipment, which could be, again, the cameras can be used by anywhere from the world. And all of this required using a uniform platform, and MS Teams was that platform. And finally, the data storage was also done via MS Teams, so that students didn't have to worry a lot and they could all work together remotely in a safe environment. So enough of the approach. I think we are here for the people. So the team really worked extensively over the summer and during the year to work on the feedback. We had several members of the teaching team ensuring that this is pedagogically effective and making sure that the students can achieve the learning objectives, but also concerning the safeties of the students. We had several technicians who not only just ensure that the experiments work, but they could be remotely operable. So all of the equipment were redesigned so that they could be accessed. We were very fortunate to work with a lot of undergraduate students who are the key stakeholders, and we wanted to get their opinion as well. And they contributed quite heavily during the whole process. As I mentioned, the teaching assistants who were really working with the students, making sure that the experience gives them enough experience of working in the lab. And then finally, the communication and the computing services, ensuring that everything runs smoothly. So in the next slide, I'll just, I can highlight some of the initiatives that the students took. This was an Instagram channel. This was designed by the students or operated by the students, telling us the whole process. And really, students were the key team members, if you were to think of them. And these are the key stakeholders, and we took them from in the whole process, their feedbacks, starting from conception to the rollout. And this was really critical because the students are the ones who would actually experience this approach. So their feedback was extremely useful, and they were actually contributed quite heavily on this remote operation of the equipment. So let's have a look at the demo of how things look like. And I'll ask James to kindly narrate this.
Okay, so let me start this video. So this is a video that we created for the Create Labs that after we'd worked with the students in the GTAs over the summer of 2020, that we used to show the students what kind of experience they would be having. So right now you're seeing a student control remotely a control system for a rig that we have. So by using MS Teams, we could connect students to control systems for the projects they have, allowing them wherever they were in the world to actually make real changes to equipment. We also had real-time equipment observation. So when you're carrying out an experiment, as we all know, we want to control it. We also want to see and hear what's going on and be able to react to that. So by using pan, tilt and zoom cameras and Microsoft HoloLens, we could give students an authentic view of the equipment that they'd be working on. With that, we could use HoloLens to and other tools to have augmented reality, so extra information. So we used QR codes that could link to YouTube videos that would demonstrate how a valve worked if a student wanted more questions. We could use HoloLens to have embedded information. So when you're looking at the rig through HoloLens, you can also have a PID of the rig that you're looking at. So all of these tools were made available to the students to enhance their learning. We also have mixed reality mode, so you can look and see in real time instructions on how to make changes to your rigs. And involved in those, we used videos which we had created for previous years to give instructions to students. These various tools allow students to have a more immersive experience, to make them feel like they were in the lab, whether it's viewing through the PTZ camera or through HoloLens or through controlling the control system, while they weren't actually available to be in the labs. So as I mentioned before, we have approximately over 450 students in the first 3 years, and we managed to have a complete hybrid remote approach to teaching the labs with all the same projects that we'd had in previous years from face-to-face teaching. We wanted to make sure a key part of this was not just that we did this for 1 year, but we think that a lot of the opportunities that we mentioned before about giving students more of a leadership role and letting them use technology that they might have to in the future for remote control of equipment was important to be disseminated. So we made sure as a team that we tried to publish and talk about this as much as possible, including articles in the Times Higher Education Guide and on the Imperial website. There's an interview from Microsoft on our use of HoloLens and Microsoft Teams for this. And we've also published several papers on this. It's important to actually note also whether we succeeded in being able to give the students the opportunity to learn. And there's a couple of quotes that we have from this. So controlling equipment software remotely gave experience to real life engineering conditions. I think it was key for us that we've actually been able to use what was a difficult situation to enhance learning in general for the students and train them to be future chemical engineers in the best way we could. Thank you very much. That is the end of our presentation.
Thank you.
Okay, thank you very much, James and Vijesh. So it's time to take your questions. If you'd like to get in touch, now is the time to do so via the questions box. And while I give you a moment on that, don't forget there are more IChemE Award webinars coming up this week. You can find all the dates and times by visiting our website, icheme.org/global awards. Okay, we have our first question. To what extent will this carry on being part of the teaching plan going forward?
So we're intending to keep all of the tools that we have and keep it as part of the teaching plan going forward in future years, just because of the opportunities that we have. I think being able to, when we have our projects, the whole idea is that we want to give the students an authentic experience of how they might be chemical engineers in the future. And we expect them, especially as we have technology like this, to have to be able to communicate remotely with people to give instructions on how to run equipment in the future. So this will remain part of the undergraduate lab teaching until the future. Of course, we'll have students back in there and they may be giving instructions to each other rather than to GTAs, but that's still something that we expect to be part of their course in the future.
Okay, thank you. Can you say a little bit more about how the remote projects tied in with the core curriculum and how they were assessed?
So to be clear, the way that we kept this assessment exactly the same as we would normally. So the students in the different years have slightly different things, but usually they have to do some form of presentation, they have to write some form of report, and we kept those parts the same. So we did the presentations over Teams, they wrote the reports and submitted them as they usually would do. So we made, like I said, we wanted to keep the learning outcomes the same, so the things that they had to produce were the same. In general, the, let's say, what they learn on the course and their courses in general stayed exactly the same throughout that year, and we just adapted the way that we delivered it to them. So it was, from a learning outcomes point of view, exactly the same as a typical year.
Okay, thank you very much. We're going to move on to our third finalist of the day. It's the joint entry from Imperial College London, UCL and the University of Oxford. Please welcome Martina Micheletti and Jason Hallett.
Hi everybody, so apologies, my camera is not going to work today, and I can also share the slide, Cassandra, so if you can share the slide set for me, that would be great.
That's no problem, just give me one moment. Okay, thank you, go ahead.
Great, thank you. So good afternoon, everybody. So it's a pleasure to be here. I'm very honored to be a finalist for this award. My name is Martina Micheletti. I'm a professor in the Department of Biochemical Engineering at UCL, and together with Professor Jason Hallett from Chemical Engineering at Imperial, we're going to introduce the hubs and the work that we have actually done to support global health. Next slide, please. I'd like to introduce what the hubs are to this audience. So the UK government committed to invest in vaccine manufacturing to work towards some priority pathogens, and this was prior to the pandemic. Our BSRC Council organized the competition to establish really vaccine manufacturing research in the UK, and 2 hubs were awarded in 2017. We are doing research towards vaccine development work, scaling up those vaccines to larger scales of operation, resolving manufacturing challenges. And the funding comes from the Department of Health and Social Care via ODA, and the impact of our work is for low and middle income countries. Because both hubs had a critical mass of researchers, which started early in 2017-18, we kind of moved on throughout, we worked throughout the pandemic and provided support towards the COVID-19 vaccine candidates during this period. The 2 hubs are led by, one is led by Professor Robin Shattock, and Jason is going to present this shortly from Imperial College London. And I lead the VAX hub with Professor Sarah Gilbert. So this is actually a co-direction between UCL and the Jenner Institute from the University of Oxford. Next slide, please. So just wanted to highlight some of the work that we had done. as I said, throughout the pandemic, we had a critical mass of researchers working in vaccine manufacturing, and then really supported the development of some early candidates, one of which was particularly was promising and was, had lots of potential at the beginning. And this is what became the Oxford AstraZeneca vaccine. We supported upstream and downstream process development, and we supported also some automated sequencing in the clinical biomanufacturing facility in Oxford. Imperial had lots of work done on RNA technology, and there was, again, they worked towards a candidate there, and this technology is now one of the most promising to be applicable to multiple products. Some other highlights of our research: when we work in low and middle income country setting, we have to talk about novel formulation which are heat stable, and there was lots of research done towards that. We all worked on approaches that would speed up process development and have shorter timescales between when a vaccine candidate is deemed promising to when the full process is actually developed and we have a full manufacturing solution there. So we use the scale down tool, but also rapid responses technologies to this effect. And the research is crucial, but is also important to make a link to really policymakers. The team of senior researchers and staff were there, and we maintain those links to really inform our policy decisions. Both hubs were very active in training. And with the training, I mean training for our own early career researchers, which were part of the hubs, but also we organized the different trainings for the low and middle income countries manufacturers. Thank you, Cassandra. Next slide, please. So the hubs were working collaboratively, and we worked on complementary technologies, but we also had some unique features, so which me and Jason will now briefly introduce. For the VaxHub, which was the partnerships between UCL and Oxford, we looked at technologies that will support the vaccine supply to some countries. We worked on how we could translate those technologies to markets and manufacturers within the context of an epidemic threat. So trying to select technologies, engineering solutions that could work for them. Next click, please. Thank you. So the hub works to fund researchers, but also platform operations. In terms of the researchers, they work on different technologies. So people in the audience might be familiar with the ChAdOx vector, which formed the basis of the AstraZeneca vaccine. So there is a viral vector vaccine approach, but we worked on others, which may be much sort of early technologies in terms of their development, but still very promising, like virus-like particle candidates and novel conjugate technologies. The hub also acts as a funding body and supports different projects and training. In terms of the team, we had Imperial College on board, Leeds University and the London School acting as really other institutions contributing to the research. And we had a number of different companies, so some from low and middle income countries, but others, so technology providers, large and small companies that really benefited from the program. And we were all working together on towards the same aim. Next slide, please. Just to highlight a few things on this slide. So you can see 30 people across 5 institutes. So this was the critical mass that we were having within our hub. If you look at the box in the center, we managed to leverage quite a lot of funding. And this is because obviously you have a critical mass of researchers, so you interact with lots of people. And these funds are now spent towards other global health projects. And finally, if we look at the number of funded training places at the bottom in the middle from 16 different countries, that's really the places that we supported from different low and middle income countries manufacturers to come to our courses, but also organize a local one. Next slide, please, Cassandra. Thank you. So that's over to Jason to introduce his hub and conclude. Thank you.
Thank you very much, Martina. So you'll find that the hubs not only worked well together, but working in parallel, we were able to tackle slightly different challenges with slightly different approaches. The Imperial Vaccine Hub was quite a large international activity, covered 14 countries on 5 continents. Imperial held the bulk of the research activity within the UK, but we had very important partners in Nottingham, Bristol, and Cambridge, and also quite a bit of activity going on with CPI and IBSC in terms of the scale up and the ability to manufacture vaccines for new and emerging threatening diseases. One of the key things that we focused on, like the UC Helvax Hub, was the international training opportunities. And so we hosted researchers and vaccine manufacturers from a number of different countries. In fact, we had 8 different countries send vaccine manufacturers to the UK for training opportunities. There were joint development efforts with Dali and Hisson and Incepta, and also quite a large delegation from biotech that came for a couple of months to explore some of the opportunities in this area. I'll have the next slide, please. Thank you. We focused a bit more on platform technologies. We were interested in some of the approaches that could be used if a new vaccine threat emerged. If a new pandemic threat emerged, what sorts of vaccine technologies would be able to respond in a rapid manner? And so, what sorts of platform technologies would you need for the manufacturing, for the production, and also for the delivery and stabilization of those vaccines? So this employed a quality by design approach and a lot of modeling in order to focus in onto the regulatory challenges associated with distribution, manufacturing of vaccines across the globe. This activity required quite a large contribution from the Center of Process Systems Engineering at Imperial College, led by Neil Shaw, looking at how new vaccine technologies would be able to rapidly reach the market so that we could address a pandemic threat in a rapid manner. We also looked at a lot of existing and emerging vaccine platforms, such as GEMMA and baculovirus, and also some more traditional vaccine production platforms, such as yeast, looking at both the technological advantages of each one and also some of the disadvantages of each one in terms of the speed of response. Professor Shattock, who's the leader of the Imperial Vaccine Hub, of course, is an expert in saRNA, and as Martina mentioned, developed new technologies for saRNA vaccines. And we just had an announcement 2 weeks ago that AstraZeneca is going to lead the manufacturing and take this technology into market. It offers opportunities for very rapid and low-cost synthesis of vaccines, reducing greatly the time from identification of a threat to the production of the vaccines. And all of this was about decreasing risk and trying to move these technologies through the TRL steps much more rapidly. I personally got to work on the heat-stable vaccine formulations, so part of the team that Martina mentioned. And so we got to look at a number of these different platform technologies and how we could stabilize them for conditions that you would find outside of the vaccine cold chain. Since the cold chain is responsible for approximately 80% of the cost of vaccinations, it's very important in that it limits the distribution of vaccines, and therefore is the greatest factor limiting access of vaccines worldwide. And so we were looking at how we could make vaccine formulations that were stable at room temperature or up to 60 degrees Celsius for months to years in order to maximize the amount of vaccine that could be distributed globally. Could I have the next slide, please, which is the final slide. Now, part of this required a lot of engagement activity, and especially since we were working with networks and manufacturers across the globe, there are a lot of policy challenges that are unique to each individual country and a lot of opportunities that are shared between countries. So we work here in the UK with the Vaccine Task Force and also the Common Select Committee on how the UK Manufacturing Centre could respond, in this case to the COVID threat. And in particular, at Imperial College, we focused on how the supply chain issues would affect vaccine production and how those could be overcome. International collaborations with the WHO and the United Nations were quite important. As I mentioned, those One of the biggest regulatory challenges associated with vaccine distribution is that regulations in each country are unique. And so these platform technologies that are being developed, even if they can respond quite quickly to the threat in terms of manufacturing, still have to overcome the regulatory challenges in a very rapid manner if we want to introduce a new vaccine to market for a disease that has just occurred. As an example of this, in one of our media and outreach activities, Robin Shattuck and I traveled to the World Economic Forum to discuss how we would deal with vaccine challenges in developing countries. And so I gave a 5-minute talk on the cold chain challenges and how we might overcome them with room temperature formulations. This, of course, was completely forgotten because the talk immediately preceding me was by Robin, who spoke about what we would do if there was a new disease that was identified and it started to spread and caused a global pandemic from an unidentified source. And this talk was in January of 2019. And 10 months later, of course, we got to see exactly what would happen if that very thing occurred. And so a lot of these outreach activities are designed around creating thinking within governments and within institutions as to how exactly we would deal with these emerging threats. You could say we were a little bit early in this case. It would have been nice to have a lot more of the principles and practices in application before we actually had to face this. But we've learned a lot, of course, for next time. And the final thing that I would mention is that the two hubs held a gigantic webinar series at the end of the summer on exactly that topic. What did we learn from COVID-19? And so I guess for us academics, what are we going to do next time? So I guess on behalf of Martina, thank you very much. And from there, we'll be happy to take any questions.
Okay, thank you very much, Martina and Jason. We'll once again take a pause for questions. Don't forget you can use the questions box on screen to get in touch. First question, can you describe some of the challenges to teamwork and how you overcame them?
I guess I can take that. I think there were a lot of different challenges, sort of internally and also externally. I mean, the internal challenges were, I guess, often about dialogue. So how do you translate the language between people working in different areas? We were trying to apply a quality by design approach to vaccine manufacturing, and the vaccines were being developed by people in our School of Immunology, so within the Department of Medicine. And of course, the manufacturing approaches were being developed in the Center for Process Systems Engineering and Chemical Engineering. And so we had to have a lot of sort of get to know you sessions in order to help the medics understand exactly how a manufacturing process works and exactly what challenges happen when they pop up. While at the same time, we had to learn some of the challenges in working with GMP and other aspects of vaccine manufacturing that aren't quite as common within the rest of pharmaceuticals or broader chemical engineering. Internationally, I actually think that there were a lot fewer challenges. I actually, the level of enthusiasm that we got from our industrial partners and the vaccine manufacturers in the developing countries was extraordinary. And they came to London for several months, and you know, already planning the return trips. We were quite excited at you know, commercial directors getting into the laboratory and learning how yeast platforms work. It was quite an impressive display, and a lot of the technologies that were being developed actually went directly into practice. Some of the platforms for delivery almost immediately. A lot of that was shuttered, of course, by the COVID pandemic, which is somewhat ironic that a pandemic shut down a vaccine, international vaccine activity, but that was sort of the nature of things.
And if I can add to that, maybe Jason, so yeah, I totally agree with Jason. I mean, we in both hubs, we had a highly multidisciplinary team, so biologists, vaccinologists, chemical and biochemical engineers working together, and so there was definitely, at the start a challenge even in communication. There was also another level of complexity there because we are a team from multiple institutions in the UK, which all have their own in a way their own practices and in terms of research and how the groups work. So we had to overcome that, and so there was a lot of communications and team meetings. And I also echo that the enthusiasm of our low and middle income countries manufacturers, which was really great. Although I should say that it worked much better with them when we work with them face to face, and that's why we want to repurpose some of the training to be face to face rather than online. Yeah, that's what I wanted to add.
Okay, thank you very much. It is time to move on to our next presentation. So next up from Engro Polymers and Chemicals, please welcome Amir Hamza. We can see your screen, Amir, but we can't hear you yet.
I'm sorry, can you hear me?
Yes, perfect. Thank you.
Okay, so let's start. Good evening, everyone. My name is Amir Hamza. I am process safety engineer in Engro Polymers and Chemicals. It is really good to be here today presenting my work. Thank you so much, IChemE, for this forum. I will start my presentation with a brief introduction about my company, Engro Polymers and Chemicals. We are the only integrated chlor-alkali and vinyl manufacturer in Pakistan. So being a petrochemical plant, it is really important to keep your process safety aspect intact because we are dealing with high hazard processes and highly hazardous chemicals like ethylene dichloride, VCM, vinyl chloride monomers, and chlorine on our daily basis. So it is really important how we manage all these, how we do our process safety compliances, and what is our coordination among the teams as a process safety team. So my topic for today's presentation will be a teamwork, what we did to develop a coordination among different technical expertise teams. So first of all, at Engro Polymer, as I said, the petrochemical plants, it's not only us, the other petrochemical plants usually face such challenges because of the corrosive services and the highly flammable and the toxic services we usually deal at our site. So asset integrity and the reliability issues is one of the leading challenges we have to deal with. And the most importantly is how we track these issues, how we work on the identification and the rectification on the frequent basis of such issues. So that is one of the challenges, and I guess every petrochemical plant faces such issues. Then the process safety risk identifications, what methodology is being used to identify the process safety risk and how to calculate how to mitigate the risk. So it is really essential to look for these aspects and to work and to provide a suitable protections for all the major accidental hazards identified in these risk studies and the risk assessments. Then the process safety action item compliances. These action items include the risk study action items and if there is any incident, process safety incident investigation recommendation. So how you are dealing with these action item compliances, are you fulfilling or not? So this was one of the challenge we used to face at EPCL. Then there is safe operating limits tracking. It deals mainly with how you are operating your equipments. If these are the safety critical equipments with respect to process safety, then you have to be within the range of the operating limits, safe operating limits. So tracking of these operating limits, if it exceeds, it should be reflected and it should be properly investigated, is really important and challenging aspect. Focus on critical incidents. Being a manufacturing plant, you come up with many incidents on daily basis. So to identify which incident is the most critical one as with respect to process safety and what focus you required on it, what investigation level you need for it, it is really concerning. Apart from these challenges, we do face few points, like if modifications at site to keep the plant running in if there is any issues, if there are any reliability issues, to keep the plant in operation, you have to do the modifications at site. These can be a temporary or the permanent changes. So to track these temporary changes and the safe timely removal of these changes is really important, and the health assessment of these temporary changes is really important. So the companies who usually have these kind of changes should have a system in place to track these things and to get these things rectified on priority. Then the excessive number of modifications, if any plant or any petrochemical plant have excessive number of modifications so its evaluation is critical, that what process safety measures you have taken with this new modification, is it covered in risk assessment or not. So we used to face such issues. We did work, I will share shortly what we did for the mitigation of such issues. Then there is the procedural compliances, the preventive maintenance of your safety critical devices, the compliance to these preventive maintenances, and the safe work practices, the work permit protocol you are following. Is it good? Does it need improvement? Is it compliance is working correctly or not? So all these challenges, we do face these challenges. We worked on it and we developed a complete new module for our process safety. So this module was basically derived by our process safety key performance indicators. About the indicators, we do have the process safety key performance indicators previously as well, but it was our self-developed indicators and we developed it based on our experiences. But after realizing the issues and after realizing the challenges not being addressed properly, we aligned our process safety key performance indicator with the API guidelines, API 754 RP recommended practices. This API is basically designed for the indicators for petrochemical and refinery plants. So if you can see, there are few parameters that we extracted from this API, and we merged our experience with it to develop a set of parameters that in reality give us the true picture of the site, and so that we can work and we can avoid unnecessary failures and unwanted incidents at site. So first one is the safety instrumentation system testing and failures. Being on a petrochemical plant, safety instrument systems are the last line of the defense for you. If we talk about the process safety broadly, so process safety is totally about how you deal your LOPCs, how you keep your LOPCs enclosed in a equipment, in a vessel, in a line. So if there is any LOPC, your process safety systems or your process safety protections are failing there. Instrumentations testing, if your instrumentations are failing, it means you are at the risk level, at high risk level, and it can fail at any time on requirement basis. So you have to do a frequent testing on these. We developed our complete set of guidelines on this testing, and we start our testing, and if there is any failure, it has been raised to the high level management, and a proper investigation is done for it. Then the mechanical integrity, again, as I said, mechanical integrity is always an issue for the petrochemical plant. So we have a highest percentage of mechanical integrity parameters in our key performance indicators, and these parameters and these points were derived from API recommendations. These parameters, like if I have a temporary change at site, so what is the health assessment of that temporary change, how many SCDs, how many safety critical devices failures I am facing at our site, how many times I have found the inspection recommendations not completed. So all these aspects are covered in mechanical integrity part, and it is being tracked on the regular frequency. Whenever there is any compliance, we get hit for these non-compliance, and it is reflected in our KPIs that is being stewarded to the higher management level. Action item compliance, these action items include incident action items, our assessment, risk assessment action items, our safety reviews action items, and we track the action item compliances on monthly frequency. And if there is any non-compliance or if any action item is being closed with inappropriate justification, so we usually highlight such things and it is being stewarded afterward. Operating procedures and maintenance procedures, if there is any procedures overdue and it needs to be revised as per the new modifications and so it, these are being tracked through these KPIs. Demands on safety system, if we have any safety system, any PSVs, pressure relief devices or anything that failed on demand, or that if we found it stuck on the test benches, it is being highlighted here. It is an incident is raised for it. It is usually stewarded with the different forums, and then proper investigation is done on it. We take risk studies really seriously, and the recommendations developed by these risk studies, the implementation of these risk studies is really important, and we do follow it properly at EPCL. Management of change, if there is any modification at site, it should go through a proper review of by the team, the technical team that must be led by a responsible person, technical person, and they should cover all the aspects of that modification, that is process safety or personal safety. It should be covered by this management of change. So we do have a complete set of guidelines and the different forums for different types of changes. If there is any process related, mechanical related or instrument related changes, we have different forums for it, different expertise of people in those forums, and they do look for the any change of in process, in operations or the processes. Then comes the lagging part, that is basically the process safety incidents. API recommends to track your process safety incidents based on the tier classification, that is tier 1, tier 2 and tier 3 basis. So we do follow those guidelines, and if there is any incident of our tier 1 or tier 2 category, that is the highest categories of the incidents, we do get debit on our site allies, on our site KPIs, key performance indicators, that is reflected in a red highlighted sign in front of the management, and what is the issue and what are the root causes for that incident. These are properly addressed in the forums, and the action items or recommendations to avoid the reoccurrence of such incidents. So these process safety incidents are usually taken really seriously in EPCL, and the proper investigations are done for it. So if we talk about process safety, the point we follow in EPCL, the thing we have applied to all our site is that the process safety or the safety is not the responsibility of a safety department only. It is the responsibility of whole site, each and every individual, each and every employee. So based on this, we faced few issues recently about the coordination among the teams. So based on these KPIs we developed, we strengthened our team coordination of process safety. As you can see, there is asset integrity team. We have a complete whole asset integrity team at site, services teams, and their production team, and then safety team. So coordination among these teams is really important to keep the things smooth, to keep the things reliable, and to keep the plant operational all the time. So each team have their set of responsibilities defined, like asset integrity. They have critical equipment inspection, testing regimes, leakages identification, and their proper actions and the investigations. Asset system deterioration issues identification and their rectification. Just like services team, the city failures, the preventive maintenance compliances. So it is a whole teamwork we usually do at EPCL. We sit together and we see what are the issues, what is the issue if there is any inspection of critical equipment and we found any thickness less than the minimum required. So what is the issue, what should be done for it, and what actions should be required for it. So safety team along with the other expertise teams look for it and they develop a strategy, and then that strategy is being implemented after getting approved from the higher management. Just like the production team, they have the responsibility to look for the safe operating limit compliances. They shouldn't, they are being advised not to operate their equipments and the operations above and below the accepted limits. Then there is demands on safety system and the site emergency response. To keep the site emergency response equipments healthy is the responsibility of the production team, the area owners. So they are doing it really religiously. That helps to develop the systems strong, to build the system and to move towards the improvement. Then there's safety team who have other set of responsibilities like the audits and safe work practices improvement. So at Anglo Polymer, we are working as a one team to improve our process safety culture, which is really important. Being a process safety team, and for the safety culture enhancement, you have to look for the few critical points. The stewardship of the critical items for system improvement through coordination. The coordination should be so strong that there is a minimal chances of any vulnerability to skip from the coordination or to skip and cause any incident. So the most importantly is the coordination between the teams. There shouldn't be any such behavior of any there should be an acceptance criteria for every organization of every department, so that they can work on it and they can come up with a strong idea for its rectification. The improvement of risk studies identification criteria, that is really important. We have recently shifted our whole system to a risk-based framework. Risk-based framework is basically how you identify your major accidental hazards at site, and how you develop and define the controls, the existing controls you have, and then using the bow tie technique you identify if there is any requirement of other protective layers, preventive or mitigation layers for that, to prevent that major accidental hazard to occur. So development of bow ties, and then there is a development of performance standards to keep your safety critical devices or the last line of defenses intact all the time through preventive maintenances or through corrective maintenances. So if the plants or the petrochemical sites like us, if they have to improve their safety culture, they should implement risk-based framework for their work in their daily operations. The management involvement is the second most important thing. The safety culture is always driven from top to bottom. Whenever the management is keen to do things for the process safety or the safety of the employees, it is really helpful for the team to develop the things and to go for the improvement phases. So management should involve in these assessments, in these risk assessments and these identifications. Here at EPCL, we have different forums for the of higher management, where even at the CEO level there is the participation in the forum, and they look for the issues, process safety issues on a regular frequency, and advise about the improvement point of view, how to improve and all the things, how to manage the things well. So we do involve our management for our evaluations and assessments. And then the last one is the quick action on the highlighted points. If you don't do any action on the points highlighted or the vulnerable points, it will exaggerate and it will cause any process safety incident. So the early pickup and the early rectification is the key here. You have to pick these things early and to act on it. So the most important part to pick this, to pick such vulnerabilities on the early stages, is to develop your system, or is to develop your KPIs in such a way that these things are extracted from there, and to track these KPIs or the key performance indicators on monthly basis. Just like if I talk about our site, we do tracking of these API drive KPIs, performance indicators, on monthly basis, and we see what are the issues we face in this month and how we are working on it and what actions we are taking. So this kind of early pickups and the early actions will avoid you from any unnecessary incidents. So what is the basically aim? What is the basically goal for all these things? On what path we are right now at Angro Polymer? We are on the risk reduction based on our risk-based criteria framework developed recently. We are looking for how can we reduce our risk. We are strengthening our maintenance techniques. We are strengthening our procedures and aligning them as per the standard guidelines. We are improving our safety culture. We are improving our risk studies, our experiences, our knowledge of the employees. So what all these things will do, it will do a risk reduction. It will reduce the probability of any error or the probability of the failures that can lead to a process safety incident, and it will give us a reliable operation. Reliable operation leads to the enhanced integrity. If you have a strong systems, if you have the strong inspection regimes available with you, so you might have a better integrity with as compared to the other side. And what all these things will lead to is the operational excellence. You can lead the industrial domains with your operational excellence to do all the things with according to procedures. So all the discussion was basically how to develop a teamwork among your groups, among your departments, so that there is only one motive of a site, of a hazardous sites like petrochemicals and refineries. There is only one motive: how to prevent the incident, how to save your employees. So there is one motive, so you have to work for it, you have to work together for it and develop a system that will lead you towards the improvement and more sustainable and more reliable operation. So that's all from my side. Thank you so much, everyone. Let's have some questions.
Okay, thank you very much, Amir. We are running a little bit behind schedule, so we're going to move straight on to our next finalists. So thank you very much.
Okay.
Next up is Johnson Matthey, and it's Hattie Davies.
Hello. I will share my screen, and so you can see. So show my screen. Can you see my screen okay?
Yes, we can. Yes.
Oh, brilliant. Am I sharing my webcam as well to be just more
you are
inclusive?
not, and at the moment we can't see your full presentation. We can see your full desktop.
Oh, I see. Okay.
So,
can you see it now? Is that better?
Yeah, if you put it into slideshow mode, that will probably be clearer.
Right now. Perfect. How about that?
Perfect.
Yeah. Well, good afternoon, everyone, and perhaps good evening for our colleagues from Asia. And it's a lovely opportunity to be, amongst the finalists. I sat here thinking, wow, what a competition, So it's an absolute honor to be in this amazing, strong category. When we think of COVID-19 and the impact that COVID-19 has had and continues to have in lives and livelihoods all over the world, we realized something, and I guess it was brought home to us when a psychologist came and spoke to us in Johnson Matthey. And it says actually there were two pandemics going in parallel. We had COVID-19 and all that it took from people and families and jobs, but we had a pandemic that was unspoken, and in her words, she called it Black trauma. I don't know where you have been on the 25th of May 2020 when George Floyd died. The world kind of stopped. As I grew up in the UK, I don't think that was the first time a Black person in the US was murdered in that way. But this, for some reason, looked different, sounded different, and the response was pronounced. Some would say perhaps it's the effect of the pandemic. And some will say, well, it's technology. Everything was caught on camera. In Johnson Matthey, we are incredibly fortunate of having strong values that we adhere to. One of them is the one that around working together and being a team player and never being a bystander. Our response to George Floyd's death was the culmination of an employee being brave enough to come forward. Now, I want to talk to you a little bit about the networks that exist. We call them in employee resource groups, or in some businesses, it's called the business resource groups. And basically, these are volunteers from the businesses from all backgrounds. I, for one, Hadi Davis, a chartered chemical engineer. I chair the Black Employee Network, but we have networks to cater for all walks of life. And with this incredible community, we were able to step up when an employee bravely said, are we able to have senior leaders listen to lived experiences of Black employees within our business? It was terrifying. How will we, volunteers of a community, stand in front of our general counsel and talk to them about what? At a time when there was transformation in the business, there was a joke that said, are we going to lose our jobs? But 6 of us, I remember our then chair, Simon Coltress, now our head of diversity and inclusion in the business, said, you guys have come forward for us to go and share the lived experiences of Black employees in the business. Now, it looked simple, but I tell you something, you know, the courage, but also the collaboration across the team to get stories, make it anonymous, to be able to put it in themes so that it is communicated well to our general counsel. In that team, none of us has ever met the whole entire general counsel before. But through also the bravery of our executive sponsor, and I think this is so critical, because sometimes you have, okay, George Floyd died, there were people with phones, there were people with, you know, bystanders, people who felt disempowered of standing up or doing something. And together with both allies and those who go through certain types of experiences, this is a time when bravery is soaked and is so much needed. Our executive sponsor, Jane Turgood, stood up and says, you know what, I will pave the way for you. It is my turn in the GMC, and I will pave the way for you. Those conversations led to this amazing, open, honest, and incredibly vulnerable meeting. But we were just blessed to see the reception we received from our GMC. They listened. They were amazed by the stories that were brought forward, but they didn't stop there. They took it upon themselves to actually action from the lived experiences of Black employees, because the recommendation we brought forward when it comes to inclusion as a team, it is for everyone. These experiences of lack of inclusion or lack of support or respect, they're not just unique to Black employees. When you look at the session that we did in April, you will see that this cuts across. It's about inclusion for all. And our CEO, I remember, he said, yes, we have zero tolerance to any form of exclusion in the workplace. And he was so grateful and said, thank you for raising awareness at this level. For 3 months later, we had our first global head of diversity and inclusion appointed, installed and doing some great work. We were then called on with other ERGs from the Gender Equality Network, our Pride LGBT plus community, our Asian family network. We were all called to give a presentation in our leadership forum of over 120 executives in Johnson Matthey. And there we see action coming out from the shared bravery from both allies and lived experiences of Black employees. And so we're incredibly proud to kind of be in this category. And I just want us to live with this. Our vision in Johnson Matthey is for a world that is cleaner, healthier today and for future generations. Some of you in the call may know our business, because some of our teams are finalists in our other technologies, especially around decarbonization, circularity. But as a global leader in sustainable technologies, we apply our cutting-edge science, creating solutions with our customers that make a real difference to the world around us. Now, it doesn't stop from there. I remember listening to the Australians talking about people. It all comes down to people. If people feel they could come to the table, their whole selves, give 100%, is good, it's a win-win. Is good for mental health, safety for individuals, and also is the business case for business growth is undeniable. So I live with this. As teams of engineers working on safety, as teams of engineers working on diversity and inclusion, I encourage us to continue to strive for that inclusive place where all of us can come and do the best engineering possible, because this space is conducive for growth. Thank you for listening, and I wonder if you have any questions.
Okay, thank you very much, Hadi, for that presentation. We'll pause for a moment. If there are any questions, you can get in touch via the questions box as usual. Okay, we do have a question, Hadi. How do you ensure that there is continued leadership in this area, building on the work you've already done?
It's following through. That is what we have seen. And also, I think small wins. Simon always says to me, small steps, small wins. There is nothing too small, even if it is one individual at a time, to make an inclusive place, and it starts with training. So there's a big ambition for people in our sustainability targets and being accountable, and we see that coming through. So from grassroots, we will do our bit. You know, if I remember this African proverb, if you want to walk fast, walk alone. And if you want to walk far, walk together. And this is not a one quick fix thing. It is a marathon, a journey. And this journey is for my children and their children and their children to come. So to the question, I think is take small steps. If senior leaders have promised and received and given an action plan, ask them, hold them to it. Don't tire, and that is what happens. Tiredness in some of us just makes us give up. So I just say, you know, get our energies up and let us not get tired.
Okay, thank you very much, Hadi. That was a very, very interesting presentation. We're going to move on. We have reached our last finalist of the day, representing the joint entry from Petronas and Malaysia LNG. Please welcome Lee Keen Seng.
Hello everyone, my name is Lee Keen Seng. I'm a product manager from Petronas Digital. I'm pleased to share with you our Startup Excellence Life Advisory, which is a product of a close collaboration between Petronas Digital and Petronas and Malaysia LNG. If you have any questions from my presentation, feel free to drop them in the Q&A section. Or if you are watching this on demand, you can reach me via my email or my LinkedIn account shown on the slide. Stella was created with a mission to capture the tacit knowledge in order to enable smooth and consistent startup of LNG trains. The problem that we are solving is the inconsistent startup performance observed due to different approaches used by different operators based on their individual experience and tacit knowledge. As to capture the tacit knowledge of the experienced operators is a complex endeavor, especially for plant startup knowledge. This is because turnaround does not happen throughout the year, and the operators are under intense pressure during startup because of tight schedule and the risk of costly mistakes. Hence, leveraging on the digital skill set and the machine and the data science capability from Petronas Digital, as well as the domain expertise from Malaysia LNG, we came out with Stella, which is our Startup Excellence Life Advisory. It is an artificial intelligence-driven life advisory that provides real-time recommendation of the parameters adjustments to our panel operators in response to the actual plant conditions. It uses machine learning to harness the data insights from all startup executions in the past 20 years which has around 3.4 billion data points from over 1,800 sensors, and incorporated the tacit knowledge from our skilled operators and engineers to the advisory. The three key personas that Stella is built for. Our panel operators would like to carry out plant startup following the validated tacit knowledge and best practices so that hiccups and potentially costly mistakes can be avoided. Our process engineers would like to capture the tacit knowledge of skilled and experienced operators in starting up the plant so that the capabilities can be passed on to newer team members, enabling knowledge retention and continuous improvement. Our shutdown manager would like to achieve consistent and optimized startup so that the startup activities durations can be predictable for scheduling optimization, leading to higher plant uptime and more energy production. Stella is powered by machine learning and optimization algorithms. If you look at the Stella engine box in the middle, you'll see two main components. The first one is the predictive model of MCHG temperature profile. And for non-energy audience, MCHG stands for main cryogenic heat exchanger, which is the main equipment used for energy production. The predictive model is built based on using the historical data, the 3.4 billion data points that I mentioned just now, by learning the relationship between the input controllable parameters, such as the flow rates, the valve openings, pressures, and temperatures, and the corresponding output, which is the MCHG temperature profile. Now, by having the predictive model alone, we're able to predict what will be the expected outcome if we change the controllable parameters in a certain way. And this predictive model is used extensively to stimulate under different conditions and scenarios what will be the most efficient and optimized option. We then further augmented this predictive model with a recommendation model, which takes in the live data from the plant to understand what is the current process conditions, and then leverage on the predictive model and the codified tacit knowledge to generate what is the most optimal advisory. And it provides the outputs in terms of controllable parameters adjustment. For example, open a valve to 8% or maintain the pressure at 12 bar, etc. And what will be the expected outcome if the recommendation is followed. And with the predictive capability, we were also able to forecast when will the current procedure or step be completed and generate a reminder to the operators to coordinate better on what will be the next step, enabling better planning and coordination. And below are some of the screenshots of the user interface that has been developed. So we show what are the key process parameters values, and then a section for configuration of what will be the target process conditions and what are the key settings for a startup. And lastly, we'll show the advisory in both graphical and tabular form to be followed by our panel operators in order to achieve an optimized startup. Now, how is this advisory developed? Advisory is a result of seamless collaboration between Petronas Digital and Malaysia LNG. We started off with a historical startup profile generation, which we look into the overall duration and performance for each of the startups in the past. Then we zoom in deeper into the duration and performance of each of the steps of the startup itself. From there, we generate a series of summary of features or the factors that might impact a startup performance. So we perform the statistical and machine learning analysis. And this is where the expertise of Petronas Digital, especially in data science domain, comes in. We study the relationship between various parameters and how are they going to impact a startup performance. We also apply machine learning algorithms like supervised learning to identify and quantify what are the key variables contributing to startup performance. Unsupervised learning was also used to uncover the hidden relationship between certain parameters. And with all the findings and insights generated from the statistical and machine learning analysis, we then bring it to the discussions with Malaysia LNG subject matter experts. And they are our panel operators, our process engineers, our technical specialists, APC engineers, and process technologists. And normally, as we are discussing the findings or the insight generated from the data, the SMEs would come out with new hypotheses based on their experience, first principle theory, or even their instinct for us to go through this iterative process of generating the profile and performing the analysis before we come back and to validate or nullify the hypothesis. And we found this process very helpful in creating an in-depth understanding of the process behaviors, which has also gained a lot of confidence among our users that this advisory that we have built is actually something that makes sense and has been proven and tested, accepted by the subject matter experts. Another key steps that we have taken is to validate the feasibility of the controllable parameters advisory that the model is generating. And we have also verified with the subject matter experts on whether or not the past adjustment that has led to superior results is actually replicable in current process conditions. And all of this eventually become the proof point of those advisories are actually something that's implementable and also feasible for an actual startup itself. I'm proud to share that the collaboration and teamwork has actually led to very positive results. And to date, there are 6 startups that has been executed using Stellar, proving its capability to capture the tacit knowledge in enabling top-notch startup performance. If you see the 6 startups that has been executed using Stellar, 5 of them were actually ranked #1 when we compared with the historical startups in the historical instances. And in terms of duration, we have also achieved significant improvement, which has led to higher plant utilization and more energy production. And now let me play a short video clip to give you a little bit more insights on the collaboration that has flourished the remarkable results.
On how we can work together as a team with complementary skill set. So us working together in a multidisciplinary board for us to then try to have a goal for each of the stream.
Learning from someone who doesn't know LNG and try to teach us on how to start the plant. It's a very big experience. For me to listen, it's a life-changing experience. They have their insights. They are fast learners. It's about forgetting the past to learn anything.
All right, so before I end the session, I would like to give a shout out to the passionate team members from both Group Digital or Petronas Digital and also Malaysia LNG for the working tirelessly to make Stellar what it is today. The milestone that we've achieved wouldn't be possible without each and every one of the individuals. Thank you so much for your contribution and thank you for the Stellar results. With that, if you have any questions, feel free to reach out to me. Thank you very much.
Okay, thank you very much, Lee. So for the final time today, we will pause for questions. If you would like to get in touch, now is the time to do so through the questions box. And if you've been suitably inspired by today's presentations, it might be time to start thinking about your own awards entry for next year. Keep an eye on the IChemE website for more details. We plan to open for entries in early March next year. We do have a question. How might you be able to share your learning from Stellar with others?
I think the key things that we have learned in this process, in developing this product, is really the spirit of teamwork and also co-creation. So how we have started this as the representative from Petronas Digital, who doesn't know anything about LNG, eventually collaborate and leverage on the subject matter experts' domain knowledge to co-develop this together, leveraging on our skill set in digital and data analytics, while then they contribute their expertise in terms of the domain knowledge. And eventually, when we cross paths and uncovering all these actionable insights, that's when we are able to achieve great results together.
Okay, thank you very much, Lee. We have reached the moment that we have all been waiting for. It's time to find out the winner of the IChemE Team Award sponsored by Baker Hicks. Before we do that, I'd like to thank all of our finalists for joining us today and taking the time to share more details about their work. Let's start by announcing our highly commended entries, and they are Imperial College London and Engro Polymers and Chemicals. So well done to everyone associated with those projects. But now it's time to announce the award winner. Ladies and gentlemen, the winner of the IChemE Team Award, sponsored by Baker Hicks, is the joint entry from Imperial College London, UCL and the University of Oxford. So Martina, Jason, if we can get you back on the line, tell us, how does it feel to be an IChemE Award winner?
Hi, thank you so much. I mean, I'm really sorry I can't, my camera is not working right now, actually. It's a pleasure. And I mean, I think this prize is really special. I think it highlights really the crucial role that engineering has had, towards vaccine manufacturing and more global health, more in general, in addition to the amazing efforts we have had in, immunology and vaccinology research. So that's really special for me. And yeah, thanks a lot. Over to you, Jason, if you want to add anything.
Only that I can't figure out how to unmute my microphone, but yes, I think Martina said it best there. Yes, thank you, everyone. And I do think that the one thing I do want to echo the most from what Martina said is that this displays what a crucial role engineering, and especially chemical engineering, can play in battling a global pandemic. So something normally we think of as being associated with medicine, but getting a vaccine out of the laboratory and into human beings requires a lot of logistics and a lot of manufacturing know-how. So thank you, everyone.
Great, thank you very much, and congratulations once again to everybody associated with our winning project. A big thank you as well again to our sponsor Baker Hicks. We've still got more IChemE Award webinars to come over the next couple of days. We'll be back tomorrow to announce the winners of 2 more awards. I hope you can join us. But for today, that is all. Thank you for joining us.